Hello and welcome back. I hope everyone is well and have a safe place and have electricity and have internet connection and everything is fine. If you have a problem, please let me know so I can help. Otherwise, I would like to start again and to continue our journey into statistics and analytics. And today we are going to talk about probability theory. We are not going to focus so much on the R code because I want again to make sure that everyone with me on the subjects. So what I did was, first of all, quiz number 1 on descriptive statistics. It's until Friday, September 22, and I would like you to do that. Again, I will be very soft on grade. I'm not concerned about the grade right now. I want to keep you back in track. So today's probability theory will be on the soft side, even though it is part of what we are going to do throughout the semester, and I will try to make more concise and show you the code in the next module. I did not change the syllabus as it should be, saying that we did not have a class last week, but instead I left it as it is, but I changed the model number 4 to September 18, and you have a week until next week to finish this model. So let's start with probability and what does it entail. The issue of probability is probably, I'm sure most of you tried to gamble in one time or another, and this is the idea of probability. How can we make a predictions about the next move? So I'm going to outline two basic things here. First of all, the probability theory, what does it entail? And then I'm going to review a little bit about Bayes' rule or law that is helping us to give more conditions to our prediction. So let's start with a basic experiment. Everyone has, I hope you remember from high school in statistical class that you have a flip a coin. So you have a random experiment when you are in the pursuit of telling is it head or tail. And this is something that we often do when we are a group of people or by ourselves. But also we have the experiment, which means that we are collecting all the evidence from the experiment to predict the outcome. And in exam marks, we often use numbers, example 0, 1, 2, or 100, or assembly line a time. How long does it take you to replace your tire in your car? Or the grade, a course grade. What did you get those in the courses, and how much time did you spend? So in probability, or when we are approaching probability, there are 3 types of approaches. Classical approach, which makes certain assumptions such as equally likely or independence about the situation, and I will talk about it more. Relative frequency is the second option, which is assigning a probability based on experiment or historical data. And subjective approach, assigning probability based on the our assignment or our judgment to the condition, and that is Bayesian approach. The classical approach is that if the experiment has a possible outcome or equally likely to occur. And this is a method that is always assigning 1 versus the number of outcome. So if we are going to roll a dice, we have the sample space and we have the probability, and each sample space has 1 to, if it is the sample say 6 or in this case 2, we have the ability to calculate the chances of occurrence. So what about random selecting students and observation the grades? We can assign female and male and female as S, and are those half a sample space? Again, this is something that I want you to go. I will assign you reading on the subject. I want you to make sure that you understand the idea here. So experiment. If we are rolling 2 dice and summarizing the number, we need to count the space. The space is to all 6 possibilities. So in this case is 1 to 36, and if it's 7, if it's 6, it's 6 divided by 37. So the sample space is really important. And again, if you are running into problem with the idea of a sample space, let me know. I will provide you more information about that. But for that assumption, this is a really foundation of the classical approach. Everything has to be assembled based on the total number of sample space. The relative frequency approach is the second approach, and this is an example of that. In my old days, we used to talk about the computer stack. What did they have in display or in the back of the store? And so in this case, we have a record of how many desktops were sold and how many days. So in this case, we can construct or estimate the probability of event, and that is the desktop sold in a given day. So in this case, we are starting with this desktop sold, the number of days, and we are calculate that based on the month. So 1 divided by 30, 2 divided by 30, 2 divided 10 divided by 30, and so on and so on. So in this case, when we are talking about 40%, that will sell 3 desktop of any day. That's how we calculate the probability with regard to relative frequency. The next subject is subjective approach. It is what we are judging as our approach to make that more accustomed to what we observe from our own eyes. So the idea here is you drop this course, or the NSA successfully land a man on the moon, or your girlfriend say yes when you ask her to marry you. So, or boyfriend say yes when you ask her to marry you. Those are subjective, and this is what we need to know about probability on that. In this case, we are talking about the probability of event, which is the sum of the probability of the sample event that constitute the event. And in this case, we're adding up the numbers. And so in this case, assuming a third die, 1, 2, 3, 4, and 5, and 6, and we're giving a value, and we add them up together. When we are defining the probability, we are talking about space. And again, sample space is the possible outcome of the experiment. And the event is a subset of the possible outcome. And the probability of event is the number assigned to the event. How do we assign to the value? It's really important, because if we are assigning smaller than the 0, equal to 0, or any other assignment, that gives the probability more ability to outcome the probability. And again, this is personal assignment. You are assigned to it and you give it the value, or sometimes someone else give it a value, but this is something that we assign a value to. So again, I I'm really concerned about the concept, and I'm going to repeat it again just to make sure that everyone with me on that idea. So the experiment is the process in which the observation is obtained. An event is the outcome of the experiment. Usually we capitalize it by a capital letter, the basic element of which the probability is applied. When the experiment is performed, it can happen, or it either can happen or cannot happen. And this is something that is really important. So, event that cannot be decomposed is called a simple event. And it is really the idea of probability. So each simple event will be assigned probability measuring how often it occurs. So the set of all the events of the experiment is called the sample space S. So in this case, again, I have a simple events, and the space is what I counted all together in order for me to have the idea what it is counted for. And this is what it is stand for. Event is also a collection of one or more simple events. So if we toss a die and the odd number can be a number is smaller than 2, and so this is what we are coming into, and this is what we are assemble in our probability. So in this case, E1, E3, and E5, and E3, E4, E5, and 6 will be the B. So in this case, we have two events that we assemble together in order for us to calculate the probability. The probability of event is usually equal to the sum of the probability of the sample event obtained in A. And so the formula for that is the P, the event of A, equal to N multiplied by the sample of event of A and the total number of events. So in this case, this is what will come out of it. If we toss a coin twice, this is what will come out of it. So head and tail, this is what will outcome, and this is the result of it. And so we will say in formula that it is PE plus PE2 and PE3, and it will be equal to the following probability. So in this case, it will be at least 3 divided by 4. But this is not the whole nature of the universe. We also have naturally exclusive event. That events that are mutually exclusive if they cannot happen at the same time. It doesn't happen to all the events. It happens to when we cannot happen at the same time. If we toss a coin, it cannot have head and tail at the same time. So in this case, this is mutually exclusive events. So if A and B are mutually exclusive events, then the probability of A happening or the probability of B happening has a formula. PA plus PB will be equal to or A and or B. And so we have some ideas what to do with that. But we also have a joint probability. A joint probability is that when A and B stand for the probability that both events will happen, it will consist of together. So we will need to add them together in order for us to say that they are joint probability. But we also have, again, this is the conditions that I talked about when we are considered about probability. One of them is independent events. And independent events are that occur when one of the events does not affect on the other outcome of the event. So, for example, if you throw a die and a coin, and the number of die does not affect the number of the result of the coin, this is independent. And if you have A and B are independent, then we have another formula for the independent event. So in this case, A and B, and it will be equal to PA multiplied by PB. So two events in case of it, and this is what we will come out of it. And again, this is a formula, for example, for men versus women, success versus failure. And we have, if the patient is a woman and B is the drug fails, so will the event A will be independent of the event B. This is something that we can test in order for us to calculate the result. So again, this is the outcome. This is what we will consider, and we can say also it can be disjoint event of non-equal to the independence. So if A is independent from B, so B is independent of C, and will A be independent of C? And this is something that we need to be concerned when we are talking about the independence. But we also have a conditions. If A and B are events with smaller than A, their condition probability of B is given A is, and we formalize it as A multiplied by B divided by A will give us the condition of the probability B given A. So, and again, this is how we calculate again the drug test with the patient of a woman. If she succeed or fail the drug test, and this is the outcome of that. So given A is independent from B, what is the relationship between A divided by B or and A? So this is what we are accounting for. Event A and B can also be conditionally independent given C. And again, another variable into the game. So until now, we talked about two variables, and now we are adding the third variable, the C, and we're trying to capture that in a formula, so it will allow us to calculate the outcome based on the condition. So an example, there are three events, A, B, and C, and this is what we know, that probability A equal to probability B equal to probability C. It's 1 divided by 5. And if we will add them together, we will add up something else. But based on this calculation, we will need to know whether A and B are independent and whether A and B are conditional independent given C. So A and B we know that are independent, and they are not equal to A, and B are conditional independent. When we are talking about multiplication rule, for any two given events, A and B, the probability that both A and B occur is the following formula. And this is the multiplication formula of the probability. So we are talking about A multiplied by B, and A multiplied by B, giving that A occurs, and the formula is A multiplied by B divided by A. So that again, if the events of A and B are independent, then the probability that both A and B occur is in this formula. Example, in a certain population, 10% of the people can be classified as being high risk of a heart attack. 3 people are randomly selected from this population. What is the probability that exactly one of the three are in high risk? So we need to define what is a high risk. In this case is age, and N is not high risk. And so we are going to apply what we have learned, and in this case exactly one high risk is equal H multiplied by N multiplied by N, and we will have the three people that we are randomly selected, and that will give us the idea of how do we find it. And so this is how we did that, and again 10%, this is how I did that in order for me to calculate that what is the probability that exactly one of the three people that we selected are in high risk, and it is equal to 0.243, and based on this formula and based on this calculation. We also have additional rule. An additional rule provides us a way to compute the probability of event of A or B, both A and B occurring with a union of A and B. So in this case, we are talking about A or B, and we are saying that A plus B equal A plus B minus A and B. So we need to subtract the joint probability for the sum of the probabilities of A and B. And this is called additional rule, and let's take an example. In this case, we are talking about probability A, which is 0.11 plus 0.29, which is the probability of B2, and which will be equal to 0.4, in this case, the probability of A1. And the same goes to the probability of B, and in this case, B1. And so it's 0.11 plus 0.06, and it will be equal to 0.17. So in this case, this is how we do that. The additional rule talk about all the components at 0.4 and 0.14 minus 0.11, it will be equal 0.46, and this is the formula for additional rule, because we need to, as you see it, minus A and B. That's why we subtract the 0.0 minus 0.11 out of it in order for us to calculate. So additional rule for mutually exclusive events is if A and B are mutually exclusive, of one event makes the other one impossible. So that means that the formula for that is A and B is equal to A multiplied by B is equal 0. If the additional rule of mutually exclusive event is A or B, and it is equal to A plus B, only A and B are mutually exclusive. Example, if a large city, there's two newspapers that are published, the Sun and the Post, and we know that based on the newspaper departments from both newspapers that 22% of the city household subscribe to the Sun and 35% subscribe to the Post. A survey, and again a sample of the population, reveals that 6% of the household subscribe to both newspapers. So the question out of it becomes, what proportion of the city's household subscribe to either newspaper? So what we have here, again, we're taking what we learned on probability and the Sun or the Post, and we add it up together in order for us to calculate, as we did here, in order for us to calculate the additional rule, and in this case is 0.51. Now I want to move to a little bit more complex probability, because I cover basic, and you will have more reading on the subject, and you will have also one of my favorite thing to do is to provide probability. And so you can okay, what is the probability? This is an online platform to find the probability that event occur, when the probability of event, and you can provide values to it, the probability the event does not occur, and probability of event B and A and B. So all those things that I cover in this presentation, you will be able to find it and be able to calculate it. So now we are moving to more advanced probability, and it is Bayes' bias rule, and which is given two events A and B, and suppose that the probability of A is bigger than 0. And we have a formula for that. It's a little bit more complex, and we are be able to ask questions such as, is it a rainy day today? And the grass is wet, and what is the probability of R divided by W? And in this case, we can assign values and be able to say what is the connection and what is the relationship with that regard. This is the idea behind, in a simple words, this is the idea of Bayes' rule. And again, I want you to make sure that you understand what does it entail. We are having two conditions, and we are trying to measure the relationship within them based on their formula. A and B, we divide it and we are multiplying in order for us to find it. So later on, when we will start talking about hypothesis and evidence, we will try to see if this rule can be applied and give us some indication out of it. But we have also some ideas of what does it entail. We have post and we have the prior evidence. Hold on, I'm just playing with my PowerPoint presentation that I worked so hard on. Whoa. And we have the likelihood that those events will happen. And so, as you can see, and as you'll be able to download the PowerPoint presentation, it will give you some sense why is this rule is so important when we are trying to find the conditions between something that is with a post evidence and prior evidence, in order for us to give more ideas of how to apply that. And a more complicated things that we will see, and we will learn about that later on, not in this module, about Bayes' rules and how to apply that. So again, we can apply it to three conditions. If it rains, the grass is wet, and people bringing umbrella. And so this is the formula for doing that. I want you to start thinking about formula, because we are going very soon to apply formulas to make more sense. So see if it makes sense. See if you're going to be asked to write a blog about that. See if it makes sense. See what it contains and how to apply that. So again, this is the end of my presentation on today's module. We need also to talk about R. And one of the things that I'm going to ask you to do, and this is a really good website that created by Michel Clark. I met him in 2015 in one of the R conferences, and I think he did a very good job on describing the important terms, the link, the package that he recommends us to use, and how to apply that. See if it makes sense. See if the data allowed us to use it, And he gives a very nice example of how to evaluate the likelihood, the distribution in the data, and what does it entail. I want you to post it. I want you to apply that. Follow those instructions. I don't care if you follow his example or make your own example. I don't care. But follow that. See what it makes and see how to apply that. I think you leave out the regression model out of it right now, but follow that example. Your assignment for this week is quite elaborate. So you're going to have, first of all, about probability. And you're going to have a probability of A and A1, B and B1. And I'm going to ask you the following questions. What is the probability of A, event A? And you're going to give me an answer on that. And what is the probability of B? And again, you're going to sum up the numbers and give me the solution. Example, in event A is 10 plus 20, but you have to divide it by the total amount, which is 10 plus 20 plus 20 plus 40 in order for you to evaluate the value of event A. So event A in this case is 10 plus 20, and in this case, this is how we judge it. And you're going to play with that. And again, I gave you an example with the data set and how to apply that, and try to stick with the probability calculator, see if it works. I know that I'm asking a lot, but I think overall you will enjoy that and probably will make you a smarter person. When you're going to go to a casino, you'll probably be more concerned about what it entails when you are starting gamble on money. So until next time, we are going to continue probability distribution in a more elaborate way. This is just an opening after the hurricane. And again, welcome back, and let's continue our discovery of probability distribution. Until next time, email me if you have any questions. Until next time, have fun and enjoy the week.